All right, let's talk about one of the most transformative technologies out there right now, large language models, or as you've probably heard them called, LLMs.
So I'm guessing you've probably played around with something like ChatGPT, maybe to help write an email or, just to see what it can do. But have you ever stopped to wonder how it actually works? What's really going on under the hood? Well, that's exactly what we're going to break down.
At its very core, an LLM is a very specific kind of artificial intelligence, but it's not some simple computer program. Think of it more like a massive digital brain that has basically read a huge portion of the internet. Books, articles, websites, you name it. And by sifting through all that text, it's learned the patterns, the grammar, and even the subtle quirks of how we humans talk.
And let me tell you, when we say large in large language model, we are not kidding. The biggest of these models have over 100 billion parameters. So what's a parameter? Just think of it like a tiny tunable knob. During training, the AI is constantly tweaking billions of these knobs just a little bit at a time to get better at its one main job, predicting the next word. It's this incredible scale that unlocks all the magic.
So how did we even get to a point where this is possible? Well, for decades, AI really struggled to get the hang of human language and its context. But then, one single revolutionary paper changed everything. Just take a look at this timeline. See that year, 2017? That's the moment. That's when something called the transformer architecture was introduced. Before that, progress was okay, it was steady. But after 2017, it was an absolute explosion. This new design is what made the GPT series and this whole AI boom we're living through possible. The secret sauce inside the transformer is something called the attention mechanism. You know how when you read a really long, complex paragraph, you might forget what the beginning was about by the time you reach the end? That was the big problem for older AIs. Well, attention solves this. It lets the model see the entire sentence all at once and figure out how important each word is to every other word. That smart highlighter analogy is perfect. It's like it instantly connects all the key ideas, even if they're worlds apart in the text.
Okay, so we've got our engine, the transformer, but how do you actually build one of these things from scratch? Well, it's kind of like a giant four-step digital recipe.
First, you gather an absolutely unimaginable amount of text data from the web. Second, you have to break all that language down into numerical pieces called tokens. Third comes the huge pre-training phase, where the model just predicts the next word over and over and over again for months. And finally, you fine-tune it, which is where you polish it to make it more helpful, safe, and aligned with what people actually want. And this is a perfect little example of that tokenization step. Computers don't understand words, right? They understand numbers. So tokenization is just the crucial process of chopping our language up into these little numerical chunks that the AI can actually process and learn from. But wait, how does a model go from just predicting text to being a genuinely useful assistant? Well, that's where a really clever technique comes in. It's called reinforcement learning from human feedback, or RLHF, and it's basically what it sounds like. Real humans rate the AI's answers, giving it a thumbs up or a thumbs down. This feedback loop is what teaches the AI to be helpful, to avoid saying bad things, and to sound way more natural and conversational. Now, as you can imagine, this recipe isn't exactly cheap. The pre-training part needs a mind-boggling amount of computer power. To give you some perspective, training a model like Google's Palm was estimated to cost around $8 million, and that was back in 2022. So yeah, this is not something you can just do on your laptop over the weekend. So you spend all this money and effort, and you end up with models that can do some incredible things. But, and this is a big but, they are not perfect. They really have two faces, one of amazing capability and one of some pretty serious challenges. Okay, this is one of the wildest things about LLMs. It's this idea of emergent abilities. As you make the models bigger and train them on more data, they don't just get a little better. They spontaneously develop brand new skills they were never explicitly taught. Suddenly, they can do multi-step math or learn a new task from just a few examples. These skills just emerge from the sheer scale and complexity. It's pretty fascinating stuff. So here's the first big paradox. On the one hand, their power is just incredible. They can be amazing creative partners, writing poems, scripts, code, you name it. But, on the other hand, they suffer from what we call hallucinations. Because their main goal is just to generate text that sounds plausible, they can confidently state things that are completely and totally wrong. And here's the other side of that coin. The power comes from their amazing ability to recognize patterns in data. But the paradox? Algorithmic bias. Remember, they're trained on text from the internet.
which contains all of our human biases. The models learn those biases right along with everything else, and sometimes they can even amplify them. It's the classic garbage in, garbage out problem.
So where is all of this heading? Well, researchers are very, very aware of these limitations, and the next wave of AI innovation is really focused on tackling these challenges head-on.
So meet the next frontier, reasoning models. The core idea is to get them to stop just guessing the next word and instead get them to think out loud. These new models are trained to write out a logical, step-by-step chain of thought before they give a final answer. This makes their whole process more transparent and, most importantly, a lot more accurate. And do they work? Oh, yeah. Take a look at these results. On ridiculously hard math Olympiad problems, a top-tier model like GPT-4o gets about 13% right. But a reasoning model? It nails a stunning 83%. That's not just a small improvement, that is a quantum leap in logical problem solving. Another huge trend we're seeing is the move towards openness. While some of the best models are locked away in private companies, others are being released as open-weight models. This is a really big deal because it lets researchers all over the world build on, inspect, and improve the technology, which speeds up innovation for everyone. And that really brings us to our final thought. At the end of the day, these models are a mirror. They're trained on the collective output of humanity. All our science, our art, our history, but also all of our biases, our fears, and our flaws. So as we build these ever more powerful AIs, maybe the most important question isn't just about the technology, but about what that mirror shows us about ourselves.